All right, so 4.2, we are now going to talk about operations. I mean, really, 4.2 and 4.3 are about operations with polynomials. 4.2 is all about multiplying and dividing. When you get into 4.3, it's about adding and subtracting. So let's kick off 4.2, talk about multiplying and dividing. Multiplying and dividing are very, very straightforward, pretty easy to do. I have provided you with the steps on this slide. So when you're multiplying polynomials, it's just like multiplying fractions. When you multiply fractions, all you do is you multiply across the top and then you reduce everything down. Although what's really cool, because we're dealing with polynomials, we can actually do a lot of the reducing first, and then we can worry about multiplying across the top and across the bottom. So when you multiply and divide, you do not need common denominators. It is adding and subtracting that you need common denominators. We'll worry about that when we get there. Okay, but multiplying and dividing, it's going to be nice and easy, I promise you. So here are the steps. When you're multiplying, you're going to make sure that everybody's factored, all numerators, all denominators. From there, you're going to simplify. Remember, we just talked about that in 4.1. Okay, simplifying is crossing off what's in common from top to bottom, and then all we do is write down what's left. You're really not doing any multiplying in this. It's really, really cool. So let's take a look at some problems. So here we go. We've got this problem. So the first things first that we need to do is we need to make sure that everybody gets factored. Okay. So when I look at this numerator right here, I have a GCF I can pull out of there, which is an x. And if I pull that x out, I'm going to get x plus 6 left. Okay. And now I'm not going to worry about that guy. Now, the other cool thing I'm going to teach you is that anytime you have a single term, like x squared or 4 that we have right there, anytime you have a single term, that is factored. There is nothing else that you can do to it. Leave it alone. Okay? So the x squared, it's good to go. The 4 is good to go. Okay? Now this x squared minus 36, now let's take care of that. We can factor that because it's a difference of squares. So we got x plus 6, x minus 6. So now that everything's factored, now we do step 2, which was simplify. Okay? Is there anything that is in common from top to bottom? Now I know that these things look separate, but if you want, just connect all the way across. It's like one giant fraction. Okay? So is there anything in common from up here, all of up here, that can cancel out with all of down here? Absolutely. We have a war of variables right there. So who's bigger? The denominator. So that means the x is going to stay down here. And this has a power of 1. So 2 minus 1 is 1. So if you want to put x or x to the first down here, that's absolutely fine. You don't have to have the power of 1 there, just so you know. Let me fix that line. That's kind of a bad fraction line. Mr. Armstrong. Well, that's a little better. All right. Is there anything else in common from up here? Absolutely. I've got an x plus 6 up here. And I got an x plus 6 right over here. So again, those two pieces cancel each other out. Okay? And since there is no more canceling, my last step said write down what's left. Well, what's left up here in the numerator? Well, again, remember this war was taken care of, so you don't have to worry about that anymore. You don't have to worry about that anymore. So what's left up at top? I've got a 4. What do I have left in the bottom? Well, we know that we had the x from the war. That was right there. And then we've got this x minus 6. And there is your answer. And again, just like what I talked about in 4.1, if you really wanted to multiply all this out in the bottom, you can have an answer of 4 over x squared minus 6x. That is also a valid answer. Your call. And that's it. That's all there is to multiplying. Factor everything, cross stuff off, write down what's left. That's multiplying. So go ahead, pause the video, give this one a try. Actually, before you pause the video, I have two more examples of this. Go ahead and give these two a try. I don't think I have one after that. Nope, then it's dividing. So go ahead and pause your video, give these two examples a try. Again, remember, the first thing you do, factor everybody. Then you cross out what's in common from top to bottom, and then you write down what's left. That's it. Give them a shot. Pause the video now. Okay, let's get out of this dual page. Let's go back to this guy. So let's do some factoring. So, and I like to do all my factoring above and below my pieces and just scratch out what I don't need anymore. Okay, so this guy first. Notice that this guy is 3 terms, a power of 3. Everybody has a k. Let's pull out a GCF of a k. Okay, so that will leave you with k squared minus 2k minus 8. Now this guy right here, this guy can keep factoring. You got to keep factoring for as long as what you can. Okay, if stuff factors, you keep going. So this piece right here factors to x minus 4, x plus 2. Now this numerator is fully factored. Okay. Down here, this is a difference of squares. So that'll be k minus 2 and k plus 2. And so that piece is factored. Okay. Over here, the 6k minus 12, that's going to factor. All we got to do is pull out a GCF because 6 can divide both of those numbers. So you get a 6, and that will give you with k minus 2. Excuse me. And then over here, this guy is going to factor, and this will factor to k minus 5 and k minus 4. Now that everything is factored, start canceling what is in common from top to bottom. So what do you see that is in common up here in the numerator with the bottom? Well, I've got an x plus, sorry, I put an x there. That should have been k. Let me fix those. K minus 4, k plus 2. Make sure you stick with their variables. Don't change them up. So, but this k plus 2 cancels down with this k plus 2. This k minus 2 cancels out this k minus 2. This k minus 4 cancels out that k minus 4. So what do we have left in the numerator? Because everybody's pretty much done canceling. What do I have left up here in the top? I've got 6k. All over, what do I have left in the bottom? K minus 5. And there's the answer. See, it's nothing crazy. You just got to factor. That's the long part of this. Once everything's factored, it's all canceling and then write down what's left. All right. So here's our final multiplication problem. Then we'll talk division. Going through factoring, everybody. This x squared minus 16, well, that's x minus 4. X plus 4, because that's a difference of squares. This 3x plus 21, that can factor by pulling out a 3. So there's that factored. This is a single term, so it stays. The 5x plus 20, that factors. Pull out a 5. That'll give you x plus 4. The x plus 7, there's nothing that you can do with that. It stays the way it is. Down here, the x squared minus 4. You might think that this is a difference of squares, but it's not. It's just a simple GCF because both of these have x's. So we pull out an x, and that gives us x minus 4. So now everybody's factored. Let's start doing some canceling. Okay, so what's in common from top to the bottom? So I see an x plus 4, an x plus 4, an x minus 4, an x minus 4, an x plus 7, an x plus 7. So, right here you can see that I have 2 x's, but if you didn't spot that, I want to go ahead and show you what would happen now. So there is more simplifying that can happen, but I'm going to show you what it's okay if you don't spot it all right away. Because if we write down what's left, so if we look at what do we have left up here in the top, we have a 12x. What do we have left down here in the bottom? Well, I've got a 3, a 5, and an x. And all that gets multiplied together, because remember, when you multiply fractions, you just multiply straight across. So what's 3 times 5? That's 15 times x, 15x. So you can see that if you don't pick everything up here, because it might be a big mess, right here you can see that, oh man, I didn't cancel everything. Just continue canceling. What's going to happen between these x's? They're going to cancel. The 12 over 15, you can put that in the calculator using your alpha y equals, and that reduces to, 4 over 5. And there you go. That's the final answer. All that craziness up there simplified down to 4 over 5. That's all there is to multiplying, guys. Factor everything, cross stuff off, and then write down what's left. So let's talk division. Division it just basically kind of adds one step in there. If I didn't have step 2 in here, if I just kind of just cross this off, right there, those are the steps that we just did with multiplying. Division is really multiplication. There is no such thing as division, just so you know. Okay? So with division, what we're going to do, these steps 1 and 2 can be switched if you want. You can do keep, change, flip, KCF, Kentucky Chicken Fried is what I call it. So you can do KCF first if you want, and then factor everybody, or you can factor everybody and then do KCF. It doesn't really matter, okay? So these 2 steps can be flip-flopped if they want, but the last 2 steps stay in order. Again, all we're going to do is we're going to make division become multiplication, because that's what the change means, okay? So I'll show you keep, change, flip here in just 1 second. So let's get over here. Let's take a look at this example, and I only have 2 problems. So if I show you these 2 problems real quick, see, there they are. These are the only 2 problems we're going to talk about. I don't think there's a third one. Nope. So we'll delete that last page. There we go. We got these 2 problems. Once we do this, that's all there is to 4-2. Okay? So if you think you want to give these a shot, go ahead, pause the video now. Give them a shot. Okay. So let's go back to single page. Let's talk about this guy. So first things first, I'm going to get everybody factored. Okay? So this one right here is going to factor into 3x, x minus, and a minus, and that will be a 2 and a 4. So there's how that guy factors. Okay? So 3x minus 2 and an x minus 4. All right? So from here, this guy down here factors into x minus 4, x plus 4, because that's a difference of squares. This guy's going to factor because it's a GCF, okay? And both of these I can pull a 9 out of, okay? So if I pull a 9 out, I get a 3x and I get a minus 2. And this guy I can pull a 5 out of and get an x plus 4. Let me fix this weird looking 4 over here. Sorry about that. So there's step 1. I factored everybody. Now step 2 is keep, change, flip. We're going to keep this first rational the way it is. Keep the first fraction. Leave it alone. Don't do anything to it. Okay? The change means that division becomes multiplication. Like I said, I told you we're going to turn this into multiplication. Okay? Because division really is multiplication in disguise. Division does not exist. All right? And last, we're going to flip. We're going to take these 2 pieces and they're going to switch spots. So the 5x plus 4 goes on top, and the 3x minus 2 goes on the bottom. Okay? And then now you just write back to what we just did. So what is in common from top to bottom? Well, this x plus 4 is going to cancel that x plus 4. This 3x minus 2 is going to cancel that 3x minus 2. This x minus 4 is going to cancel that. So what is it that we have left? And it zoom back up on me. 5 over 9. And there we go. That's it. That's division. It's the same as multiplication. You're going to factor everything, keep, change, flip it, cross stuff out. Tell me what's left. So go ahead, pause, try this if you didn't try it earlier. All right, here we go. Let's wrap up this section. So again, you got another cubic here. So you get x plus 2. And then you have x squared minus 2x plus 4. That's how that guy factors. Down here, this will factor by pulling out a GCF of x. So you get x and then x minus 3. This piece right there, it's just a difference of squares. So that's an x minus 2, x plus 2. And then that x minus 3 is factored, so it's going to stay. And now we do keep, change, flip. So we're going to keep the first. So the x plus 2. X squared minus 2x plus 4 stays. All over x and then x minus 3. Change to multiplication. Flip x minus 3. And then we've got x minus 2. X plus 2. Okay? So what's going away? What's canceling? Well, the x plus 2 cancels the x plus 2. The x minus 3 cancels the x minus 3. And that's it. So what do we have left? X squared minus 2x plus 4 over x minus 2. Not a 3, Mr. Armstrong, a 2. And there you go. If you really wanted to, again, another proper answer would have been x squared minus 2x plus 4 all over x squared minus 2x if you took the x over here and distributed through. Again, both are valid answers. And that is for 2. Enjoy the multiplying of polynomials.